Okay, hello and welcome to today's lecture, Math 1B. We're going to start Chapter 7. Chapter 7, 7.1, page 1. There we go. So, what we learned so far? We learned how to find and evaluate areas, volumes, using different techniques. In Chapter 7, we're going to go over more complicated integrals and we're going to work with new techniques to evaluate those complicated integrals. So 7.1, page 1. Integration by parts. So before giving you the formula, let me give you one example. Suppose the question says, evaluate the following integral. Integral x times sine x dx. Very well. How do we take this integral? This is x times sine x. Can I use substitution? If I use substitution, u is sine x, then du is cosine x. I don't have cosine x. I only have x. If I take x to be u, then du is going to be 1. Then what I'm going to do with sine x? So when it comes to integrals like this, we define a new method that we call integration by parts. So in general, we write it this way. We say that, okay, the integral of u dv is equal to, can be written as u v u times v minus integral v du. Integration by parts. The formula that we're going to follow to evaluate this integral. So I suggest you to form a small table. It's easier to track the integral, the derivatives, since you have u times v and v du. It means that you need to find the integral of dv and eventually find the derivative of u. So let us form a table. So you need to identify your u, you need to identify your dv. What is u? What is dv? Then on the second row, you're going to find du, the derivative of u, and v, which is the integral of dv. This is your table. Okay. So what is my u? What is my dv? There is no easy way to identify u and dv. Just note that you're trying to get rid of some of the terms. So you might say that, hey, I'm going to take u to be sine x. Let u be sine x, and my dv be x times dx. X times dx. So what's the derivative of sine x? The derivative of sine x is cosine x. What is the integral of x dx? The integral of x dx is a half x squared. Very well. Okay, I have a half x squared. Let me try to follow the formula, see if I can get something easier, an easier integral to work with. If not, I have to switch u and dv. So let us try to solve this integral by u equals to sine x and dv equals to x dx. This is my first choice. I'm trying to see which one is a good choice for me. Taking u to be sine x, dv to be x dx. There you go. Let me write down the second table for you. The second option, the second choice for u dv and du. So now suppose your u is x and your dv is sine x dx. Then du, the derivative of x, is just 1, and the integral of sine x dx is minus cosine x. Also, try to solve the integral by taking u to be x and dv is sine x dx. One of them results in a simple integral, the other one results in a more complicated, more complex integral. Okay, so I have u times v, so integral u dv is equal to uv minus integral v d, integration by parts. So this integral x sine x dx, if I take u to be sine x and dv to be x dx, is going to be u times v, u times v. So I get sine x times a half x squared minus integral v du. Okay, I got more complex, more complicated integral. This is not a good sign. This is not a good or simple integral. So what's the meaning of that? It means that this choice is not a good choice for u and d. Cross it out. So u is x, dv is sine x dx. We know that the derivative of u equals to x is 1, and v, the integral of sine x dx, is minus cosine. So let us try following the integration by parts formula. The integral of u dv is uv minus integral v d. So the integral of x sine x dx is equal to uv. U is x and v is minus cosine x. X times minus cosine x minus the integral v du. Du is just 1. So I have minus cosine, which is just positive cosine, and I already know how to find this integral. It's easy for me. So this integral is equal to minus x cosine x plus sine x plus constant of integration. This is the better choice than this choice because it gives me a simpler integral. One times dx. So to be more precise, we can write dx next to this. Okay, another example. Question says, evaluate the following integral. Here you have integral of ln of x times dx. There we go. Let us form our little table, see which one is a good choice for you, which one is dv. Let us form our little table. U, dv, I need to find u, I need to find the dv, and then take the derivative of u, then take the integral of d. Okay, you might say, hey, I only have ln of x here, so I'm going to take ln of x to be my u, and I only have one dx, so my dx is going to be just dv. So du, the derivative of ln of x, if you remember, is 1 over x times dx. Then dx is equal to dv, v is equal to integral of dx. If you remember that, this is just x itself. So let us follow the formula. This is uv minus integral v dv. What is my u? U is ln of x, ln of x. Let's put it in parentheses, times v. What is v? V is just x, minus the integral v, which is x, times du, which is 1 over x dx. We're so happy here. Why is that? Because we can cancel out x on x. The outcome is equal to x, ln of x, minus integral of dx, which is equal to x, times ln of x, minus x, plus constant of integration. Let us move on to the next example. Okay, let's erase these arrows. Example. So this example says find the integral of t squared et d times t. Very well. Okay, how do we take this integral? Let us try integration by parts. Let us form our little table and choose u, choose dv, then du and v, which is the integral of t. Okay. So remember, when you have a term with an exponent, try to take that term as your u, because taking the derivative reduces the exponent. So let u be t squared and dv be e to t dt. So this is your u and this is your d. The derivative of t squared is 2t dt, and the integral of et is et. Very well. This integral is equal to uv t squared e to t minus the integral v du 2t et dt. Very good. We have to apply integration by parts for this integral as well. Now, apply integration by parts one more time. So, your second table, now you need to identify your u, you need to identify your dv, u, dv, du, v, or the integral of dv. As I mentioned, when you have an exponent, a term with an exponent, take that term to be your u. So 2 is not very important. You can copy 2 and write it in front of the integral. T is your u, and et dt is your d. The derivative of t is 1 with respect to variable t dt. And the integral of et, you already know the integral of et is equal to e to the t. So we copy down the first term, t squared, et minus 2, and now you put everything inside brackets because you applied integration by parts for this integral. U v t et minus integral v du et dt. This integral is super easy. You already know that the integral of e to the t is equal to e to the t. So this is t squared e to the t minus 2 bracket t e to t minus e to t plus constant of integration. We can distribute this -2 inside the bracket and write it this way. T squared e to the t minus 2t e to the t minus times minus plus 2 e to the t minus 2c. Minus 2c is just a new constant, so this is just a constant. Call it c sub 1. So you can write this as t squared e to the t minus 2t e to the t plus 2 e to t plus c sub 1. Very well, let us continue. Let us make it more interesting. Very well. So we are on the last page, page 3. Exactly. So the question says, find the integral 0 to 1 inverse tangent x dx. There you go. So let us try to apply integration by parts, see what's going on. Let's for our little table, u dv, we need du, the derivative of u, and v, the integral of dv. So since the format is very similar to the formula, let us take u to be inverse tangent and dv to be just dx. Inverse tangent of x and dv is dx. The derivative of inverse tangent, if you remember, is the derivative of x, 1, divided by 1 plus x squared. With respect to x, so let us write dx next to it. And the integral of dx is equal to x. Okay, let us follow the formula. Here we have u times v, x times tangent inverse of x. Remember that your x ranges between 0 to 1. So 0 to 1 minus the integral v du, v dx divided by 1 plus x squared dx 0 to 1. Very well. In chapter 6, we learned how to find, in chapter 5 and 6, we learned how to find this integral. Let us use u sub 5, u sub method. So let u to be 1 plus x squared, du is 2x dx. So we multiply by 2, we divide by 2. We have, let us copy down this side, we're going to calculate it later. Inverse tangent x, 0 to 1, minus a half, integral du divided by u. You know that du divided by u is ln of absolute value of u. So this is x, inverse tangent x, 0 to 1, minus a half, ln of absolute value of u, and u is 1 plus x squared. So this is equal to x inverse tangent x, 0 to 1, minus a half, ln of 1 plus x squared, x ranges between 0 to 1. Then we substitute 1, we substitute 0, we substitute 1, we substitute 0, and we simplify. So this is equal to. If I plug in 1, I get 1 times inverse tangent of 1. If I plug in 0, it's going to be 0. Because 0 times any number is just 0. Minus a half. ln of absolute value of 1 plus 1. And if I plug in 0, I get ln of 1, which is 0. Inverse tangent of 1 is pi over 4. So I have 1 times pi over 4 minus a half ln of 2. Okay, 7.2. So we're going to focus on the trig integrals. We are on page 1, going over some examples. Example 1. This example says, hey, find this integral. The integral of cosine x raised to the third power. First of all, do not confuse this function with this function. Cosine to the third of x is cosine x times cosine x times cosine x. 3 times. This function cosine x to the third is cosine composed with x to the third. So these two functions are different from each other. They are not the same. When it comes to trig functions with exponents, try to run this in the format that we can eventually use trig identities. So this is our goal. Our goal is to use trig identities to simplify the integral. I have exponent 3, so I can rewrite this integral this way. I can write integral of cosine to the third of x dx as integral cosine squared times cosine x dx. So cosine to the third can be written as cosine squared times cosine to the first. Cosine times cosine is cosine to the second and times cosine. Very well. Cosine squared of x, remember now, cosine squared of x is 1 minus sine squared of x. If I have sine, then eventually I can use u sum. So this guy can be written as 1 minus sine squared of x. So let's rewrite this integral. I'm going to copy down cosine here, dx. Now I'm going to use u sum. Now, use u sum method. What is your u? U is sine. What is your du? Cosine x dx. So u is sine x, du is cosine x dx. Okay, perfect. This is equal to integral 1 minus u squared, and cosine x dx is my du. I already know how to take this integral. The integral of du is u minus the integral of u squared is a third u cubed plus constant for integration. But what is u? U is just sine x. So this is equal to sine x minus a third sine cube of x plus constant of integration. Let us make it more interesting. Still on page 1, we have integral of sine to the fifth, integral of sine to the fifth of x times cosine squared of x dx. Okay, perfect. Sine to the fifth and cosine squared. So let us rewrite this function sine to the fifth this way. Integral of sine to the fourth times sine times cosine squared dx. What I'm trying to do, I'm trying to use even exponents for my sine. Sine to the fourth is sine squared raised to the second power. I'm copying down my sine. I'm copying down cosine squared of x dx. Sine squared is 1 minus cosine squared. So this is equal to the integral. So inside parentheses, I have 1 minus cosine squared of x raised to 2. I'm copying down my sine. I'm copying down my cosine squared dx. Very well. Your best guess? Let us use u sub uv cosine, and du is negative sine dx. use sub method. U is your cosine x, and du is minus sine x dx. There we go. So I'm going to put a negative sign in front of my sign and a negative sign outside my integral. So this is equal to minus integral 1 minus u squared raised to 2. Guys, remember that your u is just cosine. So you have u squared, cosine squared, u squared. This, along with dx, is your du. So let us copy this guy down here. And cosine squared is u squared. Now, you get minus the integral. Let's write this in expanded form. Then distribute u squared. 1 minus 2u squared plus u to the 4 times u squared du, which is equal to minus the integral u squared minus 2u to the 4 plus u to the 6 du. This is easy to work with. This is minus a third u to the third minus 2 over 5 u to the 5th plus 1 over 7 u to the 7th plus constant of integration. What was u? U is your cosine, so let's substitute that. Minus a third cosine to the third of x plus 2 over 5 cosine to the 5th of x minus 1 over 7 cosine x raised to the 7th, and here we can write the constant of integration. You can factor out cosine to the 3rd, or you can leave it as it is.
Professor, I have a...
Very well. Next example for you. Now moving on to page 2. The integral of tangent of theta, the tangent is raised to the 5th power, times secant theta raised to the 2nd power. There you go. We have tangent and we have secant. Tangent to the 5th, let's rewrite this as tangent to the 4 times tangent times secant squared of theta times d theta. Tangent to the 4 can be written as tangent squared raised to the 2nd times tangent times secant squared theta d theta. At the same time, you know that tangent squared is equal to secant squared minus secant squared minus 1 is equal to, so if you remember secant is 1 over cosine squared minus 1. If you take common denominator here, you get 1 over cosine squared minus cosine squared divided by cosine squared, which is 1 minus cosine squared of theta divided by cosine squared of theta. But 1 is sine squared plus cosine squared, we get sine squared divided by cosine squared, which is tangent squared of theta. So secant squared minus 1 is tangent squared. So instead of tangent squared, we can write secant squared minus 1. So this is equal to the integral secant squared minus 1 to the second times tangent times secant squared theta d theta. So now let's take u. So I'm using u sub method. Let u be equals to secant theta. Secant theta is 1 over cosine. Du is equal to minus cosine theta raised to -2 times the derivative of cosine, which is negative sine theta d theta. So du is equal to tangent theta secant theta d theta. Perfect. So here you get the integral of secant squared theta minus 1 raised to the second. You need one tangent and one secant. So we separate these into secant times secant because we need these two as du. So this is my du. This is the integral of u squared minus 1 squared du, and so this one can be written as the integral of u to the 4th minus 2u squared plus 1 times u du, which is equal to the integral u to the 5th minus 2u cubed plus u du, which is equal to 1 over 6 u to the 6th minus 2 over 4 a half u to the 4th plus a half u squared plus c. What is u? U is secant theta. So let us substitute that by 1 over 6 secant theta raised to the 6th minus a half secant raised to the 4th plus a half secant to the 2nd plus constant of integration. Okay, let us continue. And the last example. Here we have tangent to the third. D2. Okay, we have tangent to the third. We can rewrite this as the integral of tangent squared theta times tangent theta d theta. We just learned that tangent squared can be written as secant squared minus 1. So this is integral of secant squared theta minus 1 times tangent theta d theta. Now distribute your tangent into parentheses. Here you get the integral of secant squared theta tangent theta minus tangent theta d theta. Okay. Secant squared. Secant squared is 1 over cosine squared theta. Tangent theta at the same time can be written as sine theta divided by cosine theta d theta. Minus the integral of tangent is sine divided by cosine d theta. For both of these, eventually you can use u sum. So let's write this in simplified form. You get the integral of sine theta d theta over cosine to the third theta minus the integral sine theta over cosine theta d theta. The first integral, let me write it here for you. The first integral is the integral of du over u to the third with a negative sign in front of it. U is your cosine, du is negative sign, so you need a negative sign in front. The second one is cos the integral of du over u. Perfect. This is minus integral u to negative 3 du plus this integral is ln of absolute value of u. Don't forget the constant of integration. The first integral can be written as minus, you add 1 to the exponent, which is negative 2, u to negative 2 divided by u, negative 2 plus ln of absolute value of u plus c. Negative and negative, you can cancel out these two sides, you get positive. U to negative 2 can be written on the denominator, you get 1 over 2 u squared plus ln of absolute value of u plus c. But what is u? U is cosine of theta. So your integral is equal to 1 over 2 cosine squared of theta plus ln of absolute value of cosine theta plus constant of integration.